What's up guys? In this video, I'm going to be solving this hard level SQL interview question from Microsoft called Premium versus Freemium, and this question can be found in the StrataScratch website. So let's check out what the question wants us to find. So we want to find the total number of downloads for paying and non-paying users by date, and we can only include records where the non-paying customers have more downloads than paying customers. And what we want to output are three columns for date, non-paying downloads, and paying downloads, where we sort the earliest date first. And if we check the tables we have three tables here: MS user dimension with the columns for user ID and account ID, MS account dimension for account ID and paying customer, and MS download facts with the three columns date, user ID, and downloads. Now, whenever we have multiple tables with the same columns, that's usually an indicator that we have to do some kind of join to find our output. So before we can actually start solving the problem or start coding the problem in, let's make a note of what we need to do first. So we need to find the output for the three columns: date, non-paying downloads, and paying downloads. And if we look at each of the tables, we can see that we have the columns for date and downloads in the MS download facts, the third table, and the column for paying customer in the second table. And that means that we need to find a way to get all these necessary columns into a single table, right, or single output. And we can do that by using the inner join to join the first table and the second table together, since they both have the same account ID, and the first table and the third table together, since they both have the same user ID column. So let's make a note of that here. So do an inner join, first table and second table, using the account ID column, and then we want to do another inner join on first table and third table with the user ID column this time. And then after we join those three tables together, the question wants us to find the total number of downloads for paying and non-paying users by date. And when we have a keyword like total here, then we'd have to use the sum function, right? And they want us to find it for paying and non-paying users by date, meaning that we have to group them by date and non-paying users. So we can use a sum function on downloads column and then group by the date column and the paying customer column. And finally, for this part of the notes, we want to order them by earliest date, right? So we can do an order by date in ascending order. So now that we've written down our notes, let's start coding the problem in. So we can do a simple select statement. Select the columns that we want to get from the three tables: the date column, the downloads column, and paying customer column from the first table, MS user dimension, and we can give it the alias as mud so we don't have to type it out every time. Inner join with the second table, MS account dimension, as mad, and we want to join them based on the account ID column, so on mud dot account ID equals to mad dot account ID. Now that we've done our first inner join, we want to join the first and third table together now for our second inner join. So another inner join here on the MS downloads facts table as MDF on mud dot user ID column equals to MDF dot user ID. So let's run the code to see what we get. And we get this output here for three columns: date, downloads, and paying customer, right? Now the next thing we need to do is to find the total downloads and then group them in the appropriate order. So we can find the total downloads by using the sum function here, sum downloads as total downloads. And before I forget, right? Now that we've given our tables aliases, we want to specify what columns do these tables come from. So since the date column comes from the third table, we can call this mdf.date. And same thing for the downloads column, mdf.downloads. And for paying customers from the second table, so we can just say this as mad.payingcustomer. And after we find the total downloads, we want to group them by the date, mdf.date, and then the paying customer, so mad.paying_customer. After we group them, we want to order them by date in ascending order. So order by date, well, mdf.date. You don't necessarily have to mention the table alias, but it's good practice to do so in case we do have duplicate column outputs in ascending order. So let's run this again, and we get a syntax error here. Let's see. Oh, okay. Yeah, so I put the mdf dots here outside the sum function. It should be inside here, so mdf.downloads. And if you run this again, we get the correct result this time, at least, or non-error result. And we have this time we have the total downloads by date and paying customer now. So let's take a look at what the expected output should be. If we scroll up, we can click this button here, expected output, and our output should look something like this, right? The date, non-paying, and paying downloads here. Now we get something similar, I guess. The only thing we need to do is to find the columns for non-paying and paying downloads. And we can do that by going into the next step here. And before we do that, let's just create our own derived table, and we can call this as a CTE1 here. So with CTE1, which will be used in our next line of codes as this whole thing. And let's comment down what we need to do next. So we need to be able to create these extra columns for non-paying and paying downloads, right? And we can do that with using the case statement to create these conditional columns. So let's make a note here. Using CT1, we can use the case statement to create a conditional column where if paying customer equals is no, then we want to return total downloads, else return null. And this will be one conditional column for non-paying customer, right? We want to create another conditional column for paying customer next. So let's see, so create another conditional column where if paying customer is yes, then return total downloads, else return null again. And we want to name these two columns as non-paying and paying respectively. I spelled that wrong, so let's see, respectively. So let's start typing out the code. So we can do a select statement again. So select the date, which will be the first column. And then we want to create the case statement here. So the syntax goes like this, right? Case when paying customer equals to no, then total downloads, else null. And this will be one column for non-paying customer. Let's make the other column now. Oh yeah, so before we do that, we have to like end the column. So end as non-paying, comma. We can do another case statement now. A case when paying customer equals to yes, then total download, else null, and end as paying. Now we need to select it from the first table we made, the derived table CTE1. And let's see what our output looks like now. Run code. And we get this output here with the 3 columns: date, non-paying, and paying columns, right? Now this looks very close to like what we want here, right? Except we have like duplicate dates here and these like blank rows for non-paying and paying, right? And we can fix that with our next block of code where we would use one of the Windows function. So let's comment down what our next step will be. Before we do that again, we need to do the same thing as before. Create our own derived table for this block of code as CT2. And the syntax would be something like this. So we would have a comma here when creating multiple CTEs. And we can just call this as CTE2 parentheses. And let's make sure like this our syntax is correct. So select all from CTE2 should return the same thing as before. And it's not correct, so let's see. Oh, yeah, I forgot to put in the as here. And if you run this, we get the same thing here now again. So that next we need to use one of the Windows function, and you'll see what I mean. So we have the output as duplicate date values here, non-paying, null, and paying. I'm paying the values with a null and paying value here, right? So if we want our table to like look something like this, we can push all the values from non-paying down by one row. But we can have something like 2020 August 15, right? Blank blank, and then 2020 August 15 11 19, and so on, right? So, and if we want to push everything down by one row, we can use one of the Windows function like the lag function on non-paying column. So let's make a note. Push using CTE2, push all the values from non-paying column down by one row. And we can rename this new column as lagged non-paying. So we can select date, comma, let's see, and then lagged of non-paying, comma 1 over just parentheses, comma, and just select the paying column. And before I forget, we can like just name this over as lagged non-paying, from CTE2. And if we run this, we get the output here now, where it's very close to what we want as the expected output, where we have like a null row with the dates and the row containing the correct values, right? So we're almost done solving this problem. We just need to follow the last step, which is where the question wants us to find the to like include only records where the non-paying downloads have or the non-paying customers have more downloads than paying customer. And to do that, we can just use this select statement here, or like create a CT3 out of it, and then use the where clause to like filter by like lag non-paying is greater than paying column. So let's create this as CTE3. Let's see, so same syntax as before, comma here, and we can put in the width, or actually no, so CTE3 as this whole thing here, and we can make a note, select all the columns from CTE3 and filter only by rows where lagged non-paying is greater than paying. And we can just do our last select statement here. So select date, lagged non-paying, and paying from CTE3 where lagged non-paying is greater than paying. And if we run the code, we get this output here, and let's see if it matches with the expected output. So we have here date 2020, August 16, 15, 14, it matches. The second row matches, the third row matches, and the fourth row here matches as well. So now that it looks like our expected output matches, let's check our solution for all test cases, right? We can click this button here, and it looks like we did solve it based on our current code, and the execution time was about 0.007 seconds long. So that was my solution to like the SQL interview question from Microsoft. And if we go to the discussion tab here, we'll see other solutions as well from other users. And these solutions will probably be more elegant and faster in terms of runtime than my code. But when I was making this is like, I found this to be much easier to like understand and follow as well on a step-by-step approach. But the main goal is to like be able to solve this problem, right? Which this solution set does. So if you guys enjoyed this video, then please like and comment down below what else you'd want to see from this channel. If you want to see another SQL type of video, like a SQL coding challenge video, then you should definitely check out my other video I made before called like solving this medium level interview question from Google called Activity Rank, which I'll link in the description below. Until then, I'll see you guys next time.